Hi, welcome to the first class of the Information Theory course. This course will be divided into different units, and today I'll start with the first unit, which is titled Information and Probabilistic Modeling. In this unit, I'll try to define the notion of information, a mathematical notion of information, which we will be able to use for practical applications as well. In doing so, we will have to review some basic concepts of probability, which is the underlying mathematical tool that will be used throughout this course. So let's get started. Okay. So let's start with today's class with the following question. What is information? Now, when I raise this question in my class, some students answer information is power. Well, there are classes where that may be an acceptable answer. But this is not one of those classes. Here we are looking for a mathematical measure of information, a concrete notion of information that will also allow us to measure information. So to help us motivate the answer to this question, let's try to think of the following. How much information will I reveal when I answer the following questions to you? So you look at these questions. These are very simple fill in the blanks. Okay? So the first question here is, you see this letter T, you see the letter H, and then you see a blank. What do you think is the answer to the blank? Well, here is what comes to my mind. This letter can be either E, making the word the, or it can be Y, making the word die. Nothing else comes to my mind. The second question is similarly, maybe the answers which come to your mind are letters A, making the word cat, letter O making the word cot, or the letter U making the word cut. Okay. So when you see these questions, you probably already have this guest list of answers. You know that the answer is one of these three. Similarly, for the last one, the letters that come to my mind are letters H, C making it cat, P making it pat, and maybe you can have some more guesses here. Okay, but when you see this question, some guesses come to your mind. So that you already know. So given that, when I answer this question, how much information do you reveal? Let's look at some other question. Here's a very big question. What is the next word I'm going to say? Well, you will have a long guess list. Okay, and I'll say one of those words. Here's another very vague question. What is the 20th decimal place of pi? Now, if you have a computer, you can write a small program and it will give you precisely the 20th decimal place of pi, answering this question for you. Okay, but so when I tell the answer to this question to you, how much information do you think I reveal to you? How do I measure that information? So here is something we have observed, that when I ask a question, you already have a guess list of answer, but you're not sure which one is correct. When I answer, what I help you figure out is I help you narrow down your guess list to a fixed answer. I basically reduce that uncertainty. So if you take a look at this example, if I just show you letter CO, you have a guess list. It can be COOL or COAL or COAT. And suppose now I reveal the next letter to you. I tell you actually the next letter is A. Then I've reduced your guess list to now only two possibilities from three in the beginning. And that's the informativeness of this revealing of this A. That's how informative my answer A was to you. So this suggests a very simple definition of information. Okay, information is the reduction of uncertainty. That's the definition of information. Information is reduction of uncertainty. So in this course, we'll try to formalize this principle, that information is reduction of uncertainty. And in particular, to use this principle, to be able to use this information principle to quantitatively measure information, we need to figure out what is this uncertainty. How do we measure uncertainty? Okay, so we have replaced the question of measuring information to that of measuring uncertainty, and information is simply the reduction in uncertainty. So we'll justify this principle slowly. We'll build a little theory around it. And this theory will help us do many things. It will help us do compression, communication, computation, and statistics. And we seek a quantitative theory of information And this particular notion of a measure of information is simply reduction of uncertainty, will allow us to come up with a quantitative theory of information.